Good morning, good afternoon. What we're going to be looking at today is probability trees where we've got to work out a reverse problem. Now the situation we've got here today is we're told two pieces of information to help us fill in the tree diagram. But first of all, we're told the probability of someone being late and not handing in their homework is going to be 0.27. But we're also told that the probability alone of somebody being late is 0.9. So I've filled that 0.9 in straight away on my probability tree diagram there, because that's telling me the probability of someone being late. We can also fill in the probability of somebody being not late as being 0.1, because remember 0.9 and 0.1 make up the whole one, and remember these branches here must always add up to 1. Okay, so now back to this issue here, late and no homework. Okay, told that's 0.27, so in other words 0.9 times by something is going to be 0.27. So in other words, let's have a look. 9 watts make 27. If we look at this sum here, so the answer is 9.3. So the answer is 0.3. So this mystery number is 0.3. So remember, recap working it out. 0.9 times 0.3 is 0.27 because 9 threes are 27. So that means if you've got the probability of late and no homework is 0.27, the probability of no homework alone must be 0.3. So the 0.9 times the 0.3, we'll fill it in here. 0.9 times 0.3 gives us 0.27. Okay, now we've worked out that mystery number, we've almost cracked the whole probability tree, because 0.3 means no homework, so the probability you hand homework in, we can fill in as being 0.7. 0.7 here, remember our rule of 1. No homework again on this branch was also be 0.3, because remember, it doesn't matter whether you're late or not, does not bear on whether you have handed in your homework or not. They're independent events. So that's 0.3 as well. And in the same way, with our rule of 1 here, adding the two together, 0.3, 0.7 must be the probability of handing homework in. So there, we've managed to fill in the whole probability tree using that reverse method. Now normally, in the second part of an exam question, they're going to ask you something else, and you've got to use a tree you filled in to work that out. So for example, they could ask you, what is the probability of someone being late but handing their homework in? So you go along, the late is 0.9, the handing the homework in is 0.7, so you go 0.9 times 0.7, and that gives you 0.63, because remember, 9 7s are 63. They could ask you, what's the probability of somebody not being late and handing their homework in, a model student? So do I go this one? No, because there's no homework being handed in here. So they're asking not late and handing their homework in. So it's going to be 0.1 multiplied by the 0.7, 0.1 times 0.7, and careful here when we multiply our decimals, that would be 0.07, James Bond 007. Okay, right, we're going to have they could ask right at the end, not late and but not handing the homework in. Just to finish it off, that's one branch they could ask you about. So if you wanted to know the probability of being not late and not handing homework in, it will be 0.1 multiplied by 0.3, 0.1 times 0.3, and that will give you 0.03. So you could work out any branch you want or any combination they asked you just by multiplying along the branches based on the numbers that you've put in. So to recap, reverse probability trees. First of all, you'll always be given two pieces of information. You'll be given the information about one aspect and then you'll be given the information about a combination. You've got to work backwards to find out what the probability of the second aspect was, in this case no homework. Once you've done that, that will enable you to fill in all the branches of the probability tree. You then use those branches of the probability tree to work out individual combinations that they could ask you in the second part of the question. So there you go, probability trees, reverse problems.